Hello, everyone. We are back again to our math journey, and I hope each and every one of you is doing very, very well. If you haven't subscribed to our channel, I'd like you to do us a favor by subscribing to Tutoring Made Easy. We also welcome comments and suggestions, so feel free to drop or leave us any comments below. Today we are going to continue from where we ended the other time. We are still practicing questions on indices. So this is the second part of the video. We're going to look at the first problem. We have a first problem at hand. And that first problem says if you have, let's say, you should simplify 56 whole number to the power of 1 minus 56 whole number to the power of 0. This will look scary at first, but if you look closely, you realize that it's a very simple problem. So the first thing is to introduce our equal to sign because there's no equal to sign in the problem. So equal to sign should come. And still have our 56 to the power of 1 minus 56 to the power of 0. Now, if you look at this carefully, you realize 56 to the power of 1 is the same thing as just 56. Also, remember that we said that no matter the number, if you have a million, if you remember from one of our laws, you have a million to the power of 0 is 1. No matter the expression, to the power of 0 is always 1. So this one right here is 1. So minus 1. And then we're going to have 55 as our answer. So at first it looks scary, but if you look very closely and observe it, you realize that it's a very easy problem to solve. Now we're going to look at our second problem. And the second problem says that we should express 27 whole number to the power of 1 over 3. We should simplify it. Now, I want us to look at this carefully. You see this power here is 1 over 3. This whole thing is 1 over 3. But if you look at the denominator, the denominator that is in the power, the power, the denominator that is in the power is 3. It means, how can we express this 27 in terms of this 3? So basically, equal to sign will come. We have 27, don't forget, 27 to the power of 1 over 3. And I'm asking, how do we express this 27 in terms of 3 here? This 3. In terms of 3, in terms of indices. Now remember that in terms of 3, we have 3 times 3 gives us 9. And if we multiply that 9 by 3, we get 27. Okay, and we also know that this 3 times 3 times 3, they each have a power of 1, which leads to the rule that if the bases are the same, remember the rule, the bases are the same, we add the exponent. So it's going to have 3 whole number 1 plus 1 plus 1, and that's 3 to the power of 3. So we can easily say that if you have 27 whole number to the power of 1 over 3, we can easily say that it's the same as is the same as 3 to the power of 3, all right? And then the exponent or the power there is 1 over 3. This is the same as 3 to the power of 3 multiplied by the 1 over the 3. So in the power, we can see that in the power, we can do the power part separately. We can do the power part separately. This one here, we're having 3 times 1 over 3, and we know that 3 will cancel out. It's a factor. The 3 and this 3, they have a common factor, which is 1. So basically, we're going to get 3 to the power of 1, which is 3. Okay, I hope this helps. If it's not too clear, I'll advise that you pause the video and then you go back, and then I think if you take your time, everything will become very, very lucid and clear. All right. Now we're gonna continue doing more problems. If you're given something like on the left hand side, more of like an equation form, I know we've not got into equations, but if you're given something in the equation for, let's say you have four whole number to the power of 3 over 2, and it's equivalent to 8, um, there are signs we can consider here. And one of the signs is this denominator, the denominator that is in the power, this 2 here. Or we can look at this number and also look at that number. And we can see that there's 4 in common, but we cannot write 4 times 4 like this. But that's 16, and that's not what it's here. So what we can rather do is to write the 4 in terms of 2. So this one, we can write it in terms of 2. So we're going to have 2 whole number to the power of 2, because we know that 2 times 2 is 4. So 2 whole number exponent 2. Now remember that in the index, we already have a 3 divided by 2, which is equal to this 8 here. And this 8 here is 2 exponent 3. 2 exponent 3. 2 exponent 3 right here. So we're going to have 2 whole number, 2 times 3 divided by 2. Don't forget the rule that says that if you have am into n is the same as a m times n. So don't throw this rule away. That's what we are using now over here. So we have the 2 multiplied by the 3 divided by 2. And we also having 2 to the power of 3. Now we can do this separately somewhere. This one here, we can probably do it here. And we're going to have 2 times 3 over 2. And we know that 2 cancel out this 2. And we're going to have 1 times 3 over 1, which is 3. Okay. So we're going to have, pretty much we're going to have 2 to the power of 3. It's equal to 2 to the power of 3. And at least we've been able to prove and we've shown clearly that the left-hand side is equal to the right-hand side. Perfect. Perfect. I hope this helps. We're going to solve one more problem, and then we can end here. We're going to solve one more, and then we're going to probably end here. We're going to solve one more problem, and then we end here. Let's say that we have 10 to the power of negative 2. And we are multiplying that by 64 to the power of half. Okay. Let's imagine that for maybe a second. So, first of all, it's not so clear what we can do. We need to introduce equal to sign. It's not so clear what we can do to this. But we can apply one of the rules. And one of the rules is that we want to make it positive. We want to make this thing here positive. And to do that, we write in terms of fraction. And in the numerator, we're going to have 1 in the numerator, but divided by the denominator of 10 to the power of 2. That's the rule. Don't forget, we said that if you have a to the power of negative m, it is taking 1 dividing it by a to the power of m. And that's exactly what we have done here. And we are multiplying that by 64 to the power of half. Now, this 64 here, we can write that in terms of 2. Right? We can write that in terms of 2. We know that 2 times 2 times 2 times 2. This gives us 4. That gives us 4. And that gives us 16. We need to multiply 16 by 4 to get 64. Now, this 4 can be 2 times 2. So we need to add times 2 times 2. So 1, 2, 3, 4, 5, 6. We need 6 2's. So this is the same as 1 to the power 1 divided by 10 to the power of 2. And we are multiplying that by 2 whole number to the power of 6. And then we have our half outside. And we know that we can continue by having 1 divided by 10 squared multiplied by 2 to the power of 6 times half. And we can confidently do this somewhere here where you have 6 times half This cancel. This 2 goes into self 1 and goes into 6 3 times, and that gives us 3. So we're going to have 1 divided by 10 squared multiplied by 2 to the power of 3. And we're going to have, we're going to basically have 1 time, the numerator is going to be 1 times 2 to the power of 3 divided by 10 to the power of 2. Now, we know that we can break this 10 into 2 times 5, right? So we're going to have 2 to the power of 3. Why? Because 1 times 2 to the power of 6 is 2 to the power of 3. Divided by 2 times 5 to the power of 2. Because 2 times 5 is 10 to the power of 2. And we can rewrite this as 2 to the power of 3 divided by 2 to the power of 2 times 5 to the power of 2. Remember, we said that if we have AB squared, it's the same as A squared, B squared. And that's what we have done here. We broke the 10, don't forget we broke the 10 into 2 times 5, which we have done. And then the squared is outside. And we took the square to give, we applied the square or the power of 2 to both the 2 and then the 5. So now, don't forget we have 2 to the power of 3 divided by 2 to, sorry, let me take that again, please. Don't forget that we have 2 to the power of 3 divided by 2 to the power of 2 times 5 to the power of 2 right there. All right, let me wipe this one here. We don't need this one. Yeah, don't need that one. So we can extend this right here. We can extend it, and we say that we're having 2 to the power of 3 is equal to divided by 2 to the power of 2 times 5 to the power of 2. Now, the numerator and the denominator, we are having 2 to the power of 3 divided by 2 to the power of 2 times 5 to the power of 2. Can you see that? Now, we can be able to work this out because we said that if you have AM divided by AN, the bases are the same, so we subtract their indices AM minus N. So we're going to have 2 to the power of 3 minus 2, right, divided by 5 squared, right? What is this 5 squared in the denominator? And then this one goes up here. And we're going to have 2 to the power of 1 divided by 5 to the power of 2, which is equal to 2 divided by 5 squared, which I believe gives us 2 divided by 25. All right. So we're going to end here. If it's not a bit clear, I think I would advise that you pause the video, go back a little bit, and if you need to even take breaks, and come back to the problem again. I'd like to end here. But if you haven't subscribed, please do us a favor to subscribe. Feel free to subscribe to our channel, Tutoring Made Easy. Like this video, share it, and feel free to leave any comment that you want to leave. We welcome all manner of suggestions to our journey. All right, we'll meet again. I'll talk to you again. Take care. Bye.